Section 8.5, Drawing Lewis Structures. Lewis structures can help us understand the bonding in many compounds and are frequently used when discussing the properties of molecules. For this reason, drawing Lewis structures is an important skill that you should practice. To do so, you should follow a regular procedure. First, we'll outline the procedure and then we'll go through several examples. Number 1. Sum the valence electrons from all atoms. Use the periodic table as necessary to help you determine the number of valence electrons in each atom. For an anion, add 1 electron to the total of each negative charge. For a cation, subtract 1 electron from the total of each positive charge. Do not worry about keeping track about which electrons come from which atoms, only the total number is important. Number 2. Write the symbols for the atoms to show which atoms are attached to which and connect them with a single bond. A dash representing 2 electrons. Chemical formulas are written in the order in which the atoms are connected or the molecule or the ion. The formula HCN, for example, tells you that the carbon atom is bonded to the hydrogen and to the nitrogen. In many polyatomic molecules and ions, the central atom is usually written first, as in CO3 2 and SF4. Remember that the central atom is generally less electronegative than the atoms surrounding it. In other cases, you may need more information before you can draw the Lewis structure. Number 3. Complete the octets around all atoms bonded to the central atom. Remember, however, that you can only use a single pair of electrons around hydrogen. Number 4. Place any leftover electrons on the central atom, even if doing so results in more than an octet of electrons around the atom. In Section 8.7, we'll discuss molecules that don't adhere to the octet rule. Number 5. If there are not enough electrons to give the central atom an octet, try multiple bonds. Use one or more of the unpaired electrons on the atoms bonded to the central atom to form double or triple bonds. Formal charge. When we draw a Lewis structure, we are describing how the electrons are distributed in a molecule or polyatomic ion. In some instances, we can draw several different Lewis structures that all obey the octet rule. How do we decide which is the most reasonable? One approach is to do some bookkeeping of the valence electrons to determine the formal charge of each atom in the Lewis structure. The formal charge of any atom in the molecule is the charge the atom would have if all the atoms in the molecule had the same electronegativity. That is, if each bonding electron pair in the molecule were shared equally between two atoms. To calculate the formal charge on any atom in the Lewis structure, we assign the electrons to the atom as follows. All unshared or non-bonding electrons are assigned to the atom on which they are found. For any bond, single, double, triple, half of the bonding electrons are assigned to each atom in the bond. The formal charge on each atom is then calculated by subtracting the number of electrons assigned to the atom from the number of valence electrons in the isolated atom. Now let's illustrate the procedure by calculating the formal charge on the carbon and nitrogen atoms in the cyanide ion, which has the Lewis structure of triple bond Cn negative. For the C atom, carbon atom, there are 2 non-binding electrons and 3 electrons from the 6 in the triple bond, for a total of 5. The number of valence electrons on a neutral carbon is 4. Thus, the formal charge on carbon is 4 minus 5, which is negative 1. For nitrogen, there are 2 non-bonding electrons and 3 electrons in the triple bond. Because the number of valence electrons on a neutral atom is 5, its formal charge is 5 minus 5 equals 0. Thus, the formal charges on the atoms in the Lewis structure of cyanide are. Notice that the sum of the formal charges equals the overall charge on the ion, negative 1. The formal charges on the neutral molecule must add to 0, whereas those on the ion add to give to the overall charge of the ion. The concept of formal charge can help us to choose between alternative Lewis structures. We'll consider the carbon dioxide molecule to see how this is done. As shown in section 8.3, carbon dioxide is represented as having 2 double bonds. However, we can also satisfy the octet rule by drawing a Lewis structure having 1 single bond and 1 triple bond. Calculating the formal charge on each atom these structures would have. The triple bond would have negative 1, 0, positive 1. the double bond 0, 0, and 0. Note that in both cases the formal charges add up to 0, as they must because carbon dioxide is a neutral molecule. So which is correct? As a general rule, when several Lewis structures are possible, we'll use the following guideline to choose which one, the most correct one. We generally choose the Lewis structure in which the atoms bear formal charges closest to 0. We generally choose the Lewis structure in which any negative charges remain on the more electronegative atoms. Thus, the first Lewis structure of carbon dioxide is preferred because the atoms carry no formal charges and so satisfy the first guideline. Although the concept of formal charge helps us to choose between alternative Lewis structures, it's very important that you remember that formal charges do not represent real charges on atoms. These charges are just a bookkeeping convention. The actual charge distribution in molecules and ions are determined not by formal charge, but by a number of factors including the electronegativity differences between atoms.